Hey, Vlad here, devinsideyou.com. Welcome to another video. In the previous video, we learned about an awesome correspondence between mathematical proofs, computer programs, and category theory. And today we're going to learn about functional error handling with cats. Let's get right to it. As always, I'm in an Ubuntu 18.04 virtual machine, and I'm using Windows as a host, and the virtual desktop feature in Windows gives me shortcuts to switch back and forth between them. So I'm in Windows like this, and I'm back in Ubuntu like that. Alright, so a couple of years ago, I already made a video about error handling, and it was part of the Scala as your first programming language playlist. That video, and the entire playlist, in fact, was clearly targeting absolute beginners. This video was supposed to be a bit more advanced, but since the script for this video got too long, I decided to split it into two, and so this one is still gonna be very basic, and the other one, well, not so much. The main reason I decided to make this video is because in the beginning of this playlist, in the video about Chimney, I actually covered an example with validation, and we sort of rushed through it for no reason at all. My bad, shouldn't have done it. And so today we're going to take it slow and cover the basics. We're going to play a lot with cats today, and yes, pun intended. In fact, this video is going to be almost like an introduction to cats. And in the next video, we're going to learn about applicative functors, which I wish were at least as popular as monads. All right, so let's begin. The typical gateway drug into libraries like cats, or into functional programming in general, is error handling. Well, functional error handling. So I'm going to assume that you're barely familiar with cats, and maybe you know about four comprehensions or a bit about monads. Maybe you don't understand them completely, but at least four comprehensions don't scare you. If you have seen my playlist about monads, you should be good to go. So as in most of my videos, let's just go and start by creating a playground. I'm going to switch into my dev folder, which is absolutely empty, and I'm going to do spt new dev inside you. And yes, if you have seen my video about ZSH, this is just a plugin for ZSH, which looks into my history and suggests me this command to autocomplete. So we're gonna use one of my jittery templates, which is in dev inside you Scala CG8. I already have a video about that. And then we're gonna name the project Playground, and then we're gonna open it with Visual Studio Code like this. Okay, let me press enter and just wait until SBT starts and starts downloading the template. All right, so let's call it Playground, as I do in most of my videos. Organization dev inside you, and let's just do dev inside you this time, like this. And now it's going to open it with Visual Studio Code like that. As I'm already mentioning in pretty much all of my videos, I'm using this template for my actual projects, and when I'm recording tutorials, we're going to go to the build and disable a couple of things. So not now. Let's go into the build. So we're using Scala 2.13.1. We're just going to remove pretty much this one line. Okay, that's pretty much everything we need to do. And as I already said, we're going to play with cats. So I'm just going to do org type level and like this, and it's called cats core, and the current version is 2.1.0. Also, just for today, in functional programming, the types, they kind of get too long. So we're going to go into the Scala FMT config, and we're also going to do max columns equals 120 like this. In fact, I believe it's max column like that. I'm always confusing it. All right, so let's now import the build. While it imports, I'm going to go to build properties, and I'm going to show you that currently we're using 136. So if you want to follow along, you can do the same thing, like the same thing as I typed in here, spt new dev inside you Scala C.G8. However, I'm always keeping this template up to date. So if you're watching this video, a couple of years ago, all the versions, they might be a bit different. Let's close everything. Let's open the main. And you know what? Just for fun, let's today just also use bloop for running our application. So let's just do bloop run playground. How perfect that it just finished importing. There we go. Okay, so we have a simple main method. Scala FMT woke up. There we go. Compiling, compiled, and hello world. All right, cool. Now, when you start playing around with cats, you basically need 3 imports. So this import, you will almost never, maybe sometimes you'll need it. This one you will need very often. And this one you will need pretty much all the time, right? So if you're starting out with cats, always have these 3 imports and you're going to save yourself a ton of headache. Now, we have seen in the previous video how a lot of things are isomorphic to each other. You know, we've seen either and, option and try and all of these things. Now, cats is a functional programming library, but it is also a utility programming library. All right, so it adds a lot of conversions between these types, and also it adds its own type called validated, which resides in cat's data over here, and we're going to play with it a bit later in the video. So we're just going to start by playing around, seeing some of these conversions. Like, one of the things that you need to know about functional programming is that functional programs, they're composed of super tiny things, and therefore functional programming is kind of very flexible in the sense that like all of these teeny tiny pieces, they can be assembled together. The word that we're using usually is composed. It can be composed together, which also unfortunately means that there are many ways to accomplish one thing. So we're just going to start by creating a bunch of these things and converting between them back and forth. And in fact, I might actually end up creating a cheat sheet. And we're going to start by creating an option, which is in the Scala standard library, right? So it's not in cats. So we're going to create a sum like this, and we're going to create a none like this. And the reason I'm showing you this is because I can't type, Jesus. All right, the reason I'm showing you this is that the type that is inferred by the Scala compiler when you're doing sum1 is actually not an option of int, it is actually sum of int. You can see it at the top, sum int. As soon as I start moving my mouse, this pop-up is going to disappear because pop-ups are weird. All right, but basically, as you have seen, the type is actually sum, and over here the type is actually none instead of being optional. Now the thing is that in functional programming, we kind of don't like subtype polymorphism. However, we still need a form of ad hoc polymorphism, and what we usually use is type classes, and I already have videos about implicits and type classes about all of that stuff. I'm sure you can find them on your own. And so what cats does is cats adds implicits to allow you to instantiate types like options for example, in such a way that these methods, they always return an option. Okay, so the next thing that we're going to do is we're going to do print line 1, and you can just say dot sum because we have this import over here, and also you can do none like that. Right, so with a small n, and also you can specify the type like this. Okay, so I'm going to save this and I'm going to ask it for the type, and you're going to see that the type is actually an option. You see it at the first line, so it's on the same level as line 5. As I already mentioned, as soon as I start moving my mouse, the pop-up is going to disappear, so I can't actually point to it. But you can see the type is option int. Over here you see the type is none. I'm sorry, the type is option a, and over here, well, actually kind of don't see the type over here. Let's do val something equals none like that. Not 1, none like that. Okay, so I want to show you the type. Yeah, so the type is option nothing. Okay, and for this one, the type should be option of int. Yeah, there we go. I'm not sure why I didn't actually show it over here. It should have showed it to you. Well, it says option A, but in this case, the inferred type is actually nothing. So this is option of nothing. Since we're already talking about option, this has nothing to do with cats, but you can also create an option of null like this, sum null, right? So there's going to be a null inside of the sum, and in functional programming we don't like nulls anyway. I mean, actually nobody likes nulls. All right, you cannot do null.sum like this. However, if you instruct the compiler that this null is actually something like a string, it will actually allow you to do this. Maybe it will actually show you the type. Well, it's an option string. Okay, that's not really helpful. Okay, I'm just simply doing this to remind you that in the Scala standard library, right, this has nothing to do with cats. You can actually use the option constructor, right? So we're doing option 1 instead of sum of 1, right? And if you put a null in there, you're going to see that it will actually be converted into null, right? So it's not a sum of null, it will be converted into null, right? So this is a special factory that basically it contains a null check in there. Maybe in fact we can jump in there. Yeah, we see the apply. That's all it does, right? It checks for null, then it's none, otherwise it's a sum. Nothing really super complicated, but since we're already talking about option, I thought that I will point this out. Now the next thing that we would like to do is we would like to play around with either. However, before we do that, we're going to make a gigantic leap in complexity, and we're going to talk about functors. And believe me, there is a reason why I do this, and we're going to talk about this more in the second video, but it is actually necessary. So what we're going to do is we're going to create a new file, and I'm going to call it I'm just going to call it fplibrary.scala like this, and I like to do my packages like that. Okay, package playground. We're going to create a package over here package over here, we're going to call it FP library like this. Okay, and so what I'm going to do is I'm going to go and I'm going to start creating a functor, right? So a functor is something that is parameterized with a type which is usually called f, which is kind of unfortunate. I actually find it a bit confusing, but there is a reason for this. Okay, so a functor is something that has a function called map, and this function, it lifts a function that goes from a to b to a function that goes from f of a to f of b, like this. Now this is a typical this kind of notation is a typical notation that is closer to the category theory. And in Scala, which is a mixture of object orientation and functional programming, we like to use a different notation. So we rearrange the types a little bit, and we usually write a map like this. So we have AB, we have f of a like this, f of a, and then we have this function. It's going to be a current function, a to b, like that, and it's going to create an f of b. Now, most people are familiar with functors, maybe not in depth, but basically, we can implement each one of them in terms of the other. Okay, so for example, over here, we need to say, okay, so we need to create a function that goes from f of a to f of b. So let's say that we have an f of a. How can we produce an f of b? Well, we can actually call map, right? So we can call this map over here. Okay, so what does this map want? Well, it wants an f of a, and we already have an f of a. So let's give it an f of a. Okay, so what does it also need? Well, it also needs the function. Okay, so we can give it the function. And now this whole thing produces a function that goes from f of a to f of b, like this. And we can do it the other way around as well. When you're designing your own interfaces, please never do this, because your clients will never know which one to implement. But since this is just an educational video, I'm going to show this to you. Okay, so we basically call the other map. What does it want? It wants the function, and this should be the f of a, right? Because if you're calling map and we're giving it this function, it gives you back another function that wants an f of a. So we're giving it an f of a, and it gives us an f of b, like this. All right, now in this video, we're pretty much going to be using only this notation, so I'm just going to throw it out. But I just conceptually, a functor is something that lifts a function from a to b to a function from f of a to f of b. Okay, so let's just remove that, and let's keep this one abstract. So I introduced the functor because I really wanted to talk about applicative, and we're going to talk about applicatives more in depth in the next video. But it's actually kind of important for this one, which is why I'm doing it. Okay, so an applicative is a functor, right? So it extends the functor, right? So it also has the map function, which adds a very simple function, which is just it's sort of like a factory, right? So it's called pure usually, or point, and all it does, it actually creates basically an f of a. Okay, so you just give it an a, very simple function, give it an a, and it just lifts an a into f of a. Okay, so yes, it's a functor of the same f, like this. Okay, so a functor lifts a function from a to b to a function from f of a to f of b, and an applicative, it just lifts an a into f of a, right? Sometimes you say it lifts an a into a context of f. By the way, a small tangent. If you have seen my video about monads, when we defined our applicatives, we actually had our a as a by name parameter. Okay, this video was primarily about monads, which is why this was just a tiny crutch, tiny helper, so that you don't get distracted. But if you're working with actual I/O monads in libraries like Cat's Effect, for example, then the pure in there is defined like this. So if you wanted to create I/O, you would do something like, so I believe in Cat's Effect the apply function is actually a by name, right? So you would just do that. So you would do something like print line hello world, or I believe you can do io.delay print line hello world. However, if you do io.pure print line hello world, then it will have exactly the same signature, and so this print line will be initialized long before it reaches the pure function. Okay, just a tiny thing. Okay. All right, now I introduced this thing just because to show you that basically, since applicatives are basically like constructors, they're sort of like, in object-oriented sense, they're like factories. There's a way to create options and eithers and whatnot with applicatives. And the way you do this is, I'm not going to import this, right? So we're going to use cats. So what you can do is, you can go and you can say print line, and you can ask it to implicitly give you the applicative for option, right? So you're basically asking, hey, give me the factory for option, okay? And then once you get it, then you can go pure, right? And you can give it a 1, for example, like this, right? So why does it say application? Applicative, like this. All right. Now, inside of cats, this is a common pattern for type classes. If you have seen my video about type classes, you know this. It is a very typical thing to create a companion object for this trait applicative and to put a summoner method in there, and then the object becomes a so-called summoner object. So basically, it has a method called apply, which basically does exactly the same as implicitly, and therefore you don't even need to do this whole implicitly thing. Right, so you can just say applicative.option, basically it calls the apply, and then it gets it out for you, and then you can just call pure. And also because we're importing implicits over here, right? So applicative, it comes from cats, okay? And the next thing that I'm going to show you is what comes from cats implicits, right? So you can just basically say one.pure, and then you can just basically say option, right? And behind the scenes, exactly the same thing is going to happen, right? So it's going to find the applicative for option if it exists, and it's just going to call pure on it, okay, right? And the result types of this are always options, okay? So it's not some. Also notice that pure sort of always produces the, let's call them good values. So you cannot call pure so that it produces a none for you. We're going to talk about this a bit later. Let me show you a couple more examples, because basically, most things, they actually have an instance of applicative. So for example, you can create a list like this, 1, 2, 3, right? The regular list from the Scala standard library. But if you're creating a list with only one element, right? So like this, then you might also go and say println one.pure of list. Okay, so somewhere in cats there is an applicative instance for lists, and therefore you can do this. Obviously, this works only for one element. Okay, now let's talk a bit more about cats. So cats goes ahead and defines a couple of wrappers for lists. One is called NonEmptyList, which is a list that cannot be empty. Okay, so we can do a println non-empty list like this, and you can say so if you do like 1, 2, 3, it's not going to compile, right? So it has a special factory, so I'm going to comment this one out. In fact, let me create a bit more space like this, more vertical space. Okay, so it has just a function called .off. Okay, non-empty-list of 1, 2, 3. Okay, and if you're creating a list with only one element, you can just say 1. I mean, obviously you can just say off and then just give it only one thing, right? But you can be a bit more explicit, and you can say 1, right? And this function will receive only one element, and exactly the same as before, right? Exactly the same as in this one. You can just go and say give me one of non-empty list. Okay, oh my god, why did it autocomplete it to that non-empty list? This is what I wanted. Did it also introduce an import? No. Okay, there we go, non-empty list. You can also convert between the the list from the standard library into the non-empty list, right? So you can do something like non-empty, why can't I type today? Non-empty list like this, and you can just say from list, and you can just give it some other list, right? So for example, you can do list.1, 2, 3, and because this list, it might be empty, and we don't like exceptions in functional programming in general. This from list function, it returns an option. Okay, so if we do something like list.empty over here, it will return a none. Okay, so it might succeed, it might fail. We use option to represent this arrow in this case. Now, there's also a sort of a newer version of this non-empty list. It was added in later versions of cats. It's called NonEmptyChain, and the only difference is that NonEmptyChain also has an append with a constant algorithmic complexity. Okay, so basically you can append fastly. The constructors, they sort of they look very, very similar, but in fact for this one you can actually say non-empty-chain of 1, 2, 3. As you can see, for the non-empty and non-empty list, this actually did not work. What's happening? Non-empty-chain like this. Okay, so for this one it actually works. In contrast, like this API does not work anymore. Okay, so this function simply does not exist anymore. Okay, so the same as with this one, so you can do I mean, obviously you can just create one element by just passing it one element. Okay, you can also be a bit more explicit and do something like .1 like this, and obviously you can also do you can do a println one.pure non-empty-chain. Please autocomplete this. Yes, there you go. Non-empty-chain, same as before. The conversion from the regular list to non-empty-chain looks very, very similar, but the method is called from seek, right? So you have non-empty-chain, instead of saying from list, you're saying from seek, and then you can give it a list of 1 to 3, okay, and you can also give it a list.empty, and then it's gonna return a none. There we go. Now, since there is a non-empty chain, there is obviously also a chain. As you can see in the print lines, there's also a chain. So non-empty chain is just a special case. Creation, same thing, 1, 2, 3. Obviously, you can just give it only one element. You can also say chain dot one. You can also say same as before, one dot pure chain, right? So this was really the reason why I showed you the applicatives, because you can construct many things basically by saying dot pure. Okay, list dot 1 2 3 like this, chain from sequence. Now we're not going to play with it much, but I'm just showing it to you for completeness sake. So cats also has sets, so it has non-empty sets. Okay, so you can go non-empty set like this, and this is not going to work because like this API is sort of like older, so it's like more close to non-EmptyList. Okay, so this one is not going to work. However, this one will, if you just say dot off, and obviously you can create it with only one element, and you can do also one like this. And the reason I'm showing this to you is because it actually does not have an instance of applicative, right? So if you do that, it will say, hey, could not find an instance of applicative for NonEmptySet, okay? And also you can go and you can convert, you can take non-empty set, you can say from set. Unfortunately, you have to be very specific, and you have to give it the sorted set, collection dot immutable dot sorted set 1 2 3. All right, it only works for sorted sets. All right, so let's talk about either. As you have seen in the previous video, either is very commonly used for error handling, right? So this is either is an anonymous sum type, so it can either be left or right, and the right value is usually used for the right values, right? For the good values. Okay, so we're gonna go and do print line right of 1, and it has the same issue, right? So either is coming from the standard library, so it has the same issue that the type of this is actually right, in this case of nothing and int, instead of being either of nothing and int. Okay, so you can be more specific, right? So you can go and say right, and you can specify the types. You can say on the left I'm going to have a string, on the right I'm going to have a an integer. So we're going to do this, and then the type is going to be a right of string and int, still not an either though. Okay, so in cats you can do just one dot as right, and in this case it's going to be an either, but still of nothing or int. Okay, so it's going to be an either of, in this case b is inferred to nothing. I'm not going to show you to you, just believe me. Okay, and you can specify the type that is on the left, right? So this is a common sort of like a weird thing to get your head around this. So you're saying right, but you're specifying the type that is on the left. And the reason for this is that the compiler is capable of figuring out that on the right you have an integer, right? But you're calling this thing on an integer, so you don't need to specify the type that is on the right. You're specifying the type that is on the left, and therefore the type of this is either string or int, like this. All right. Now, if we had a type alias for either string or some sort of a, right, which is covariant, which doesn't really matter in this case. Okay, so you can go and create an alias like this. Okay, and the reason I'm doing this so that I can show you how to use pure, because pure wants an applicative, and eithers, they are right biased, so they are functorial, or they're applicatives in their right value, right? So they're right biased, and therefore we need to create an alias that will look like as if it accepts only one parameter, right? So we're basically fixing the other parameter to always be the string, just so that we can call pure, right? So that we can call one.pure, and now we can give it either string or, okay, like this. All right, so the type of this is going to be either string or int in this case, because this is an int. Okay, and the other way you can do this is by using the kind projector plugin, which is included in my template. If we go to my build real quick, we're going to see that I'm using I'm saying add compiler plugin, org type level kind projector, and we have a file called dependencies like this, and the kind projector is defined like this, right? So it's just org type level kind projector, and I believe this is the latest version. Okay, let me close this one. Let me actually close FP library like this. All right, so what you can do is you can just say one.pure, and then you can say it's going to be an either string or, and this is where the kind projector comes in, you can just say a star, or you can also use a question mark. I believe in the newer versions it's more common to use a star like this. Okay, it's actually kind of funny because you can actually go ahead and you can actually make this covariant, this star, right? It looks so weird, but you know, it compiles. I'm going to remove this one though, because I don't want you guys to start doing that. All right, so let's start playing with the left values. They're very similar, so you can do a print line left 1 like this. By the way, let's use strings on the left, just so that we can keep them more separate. Okay, so the type of this is going to be left of string or nothing, right? Because again, it's not either a string or nothing, and nothing because you didn't specify the type. So we can go over here, we can specify the types. We can say there's going to be a string on the left, and let's say that we're going to have an int on the right. Okay, so now the type of this, same as before, is going to be a left of string or int. You can also go ahead and say over here, you can say just arrow, and come on, arrow, and you can say as left. I actually kind of wish that it was called left instead of as left, but hey, that's how it is. Okay, so you can say as left, and you can also say as left and specify the type that is on the right. Remember, you always specify the type which is on the other side, okay, because it can infer that on the left you're going to have a string. All right, so the type of this is going to be an either string or int. Now, we can't use pure because, as I already mentioned, pure is for good values. However, there is a thing called applicative error, which is basically an applicative. In fact, we can also open FP library like this. And I kind of assume that you're more familiar with monads. Monads are kind of more popular than applicatives. So for monads, there is monad error, and for applicatives, there is applicative error. Okay, so you go like this, straight applicative error, right? So it needs some sort of functor, but it also needs to know the type of the error, right? So it is also an applicative, right? So it's a nice little hierarchy, and then it basically has a factory, but it can't be pure. It can be called pure because the either, for example, obviously it has instances of all of these, right? So it's gonna mix in that one, for example, and then you can't have pure twice, right? So it's already defined an applicative, and so this one is just called a raiseError, right? raiseError, it wants the A, but the thing that comes in is an error, right? It's a very weird signature if you're not used to it, right? So it says, I need to know the type of your functor, basically, right? But you need to give me the arrow so that I can produce the functor of A. Okay, this is a very weird signature, but the usage of it is kind of very simple, right? So if you wanted to use this, right, so if you had this arrow, right, you would be able to say raiseError, right, and you would give it some f, right? In our case, it's going to be an either, and then you would need to give it the e. Unfortunately, you always have to specify the e. Okay, so let's actually go and do this. Again, we're not using like hours. I'm just using, showing this to you for educational purposes. Okay, so over here, all we need to do is we need to go and we need to say print line arrow, right? And in the past we were saying .pure. Now we're going to say raiseError. Okay, raiseError, and it needs to know this other string or, right? So we're reusing exactly the same alias. However, unfortunately, you also need to specify the arrow type, right? So unfortunately, you'll also have to specify this. You can do the same thing with the client projector, but then it's going to look super weird, right? So you're going to do either string or star, right? And then you're specifying the, you're specifying the string twice. It's kind of weird. Like these type, like even though client projector is very common in functional programming, these type aliases they're common as well, right? So they actually make your code look a bit nicer. So don't go and use the client projector literally everywhere, right? Create these type aliases there. Also very common. It's a good thing to do. Now I'm not going to show it to you in our applicative error, but the proper applicative error that is defined in cats, it basically allows you to do all the things that you can do on the right hand side with the either. You can also do this on the left, right? So we have already seen the pure, right? Let me show this to you again, right? So you can do one.pure, either string or something like this, right? And you can do the left side with raiseError, right? So you can do arrow dot raiseError like this, and you can do the same thing as a string, star, and comma string like this, right? So we have seen this already, right? But you can also go and you can do one, so you can do like write one. I'm gonna mix the syntaxes sometime, even though I don't care. Let's do one dot as write like this, and you can do dot. Let's specify that on the left we have a string, and you can do map +1, right? So we're going to see a write of 2. Once it finishes compiling, we see write of 2. But you can also go and do error over here, right? You can do error, okay? Come on, error, okay? And you can do as left, and you can say on the right, I'm going to have an int, right? And applicative gives you a left map, right? So you can do left map, and now you can do something with the error. I don't know, you can do like, I don't know, reverse or something like this, okay? Right, so now it's going to go and say Rory, okay? The same thing for flat map, for example. You can go and print line one dot as write, On the left, we're going to have a string, and you can do flat map. And over here, remember that you need to produce an other, so you can actually go and say, I want to produce a left now. You can produce whatever you want. So the one comes in over here, right? But you can go and you can produce a left like this, right? Let's actually keep using this other syntax, right? So you can do dot as left, and on the right, let's say that on the right it's still an integer. Okay, so you can say over here, I don't care that it worked before, it's an error now. Okay, it's just as left now. Okay, so you can just go and sort of like ruin it. Okay, you can do the same thing for the other side. You can say I have an arrow, right? We have it as left. You can say on the right I'm going to have an int, and you can go and say left flat map. Okay, so now over here what you have is the error like this, and on the and on the right, you're going to produce some valid integer, for example, 1337. You can say as right. On the left, it can be a string like this. What did I do wrong? Oh, where does this thing come from? There we go. That's what I wanted, and we need another brace over here, like this. All right, and also I don't want you to think that you're sort of forced to keep using the integer over here, right? So you can go and say, I don't know, something like this. Okay, right? It still works. So it's basically it's exactly the same as flat map. It's just that it works on the left side. In fact, flat map actually comes from monads and not from applicative errors, right? So there's an applicative error, but there's also a monad error. So the monad error brings these this left flat map. Okay, so it's basically you kind of see these sort of parallels. As I already mentioned, there are many ways to convert between them, between either an option, for example. So you can go and create a right one, right, with a regular syntax. You can just say to option. Okay, like this. This method probably actually comes from so this one actually is defined in either, right? So you can say to option, and you can say to try, and maybe you can do so you can say like is left and other things. Okay, so you can do this, and you can do the left one. So what I'm saying is that this one is not even defined in cats. Okay, so you can do to option like this. Okay, when you go in the other way around, this particular one is actually defined in cat, so you can say either from option, and this is the one that we have seen in the video about chimney. Okay, from option, and you give it some option, for example some one, and then you give it a binary parameter which is called if none, and it's going to be an arrow like this, right? So you're basically giving it a fallback. It's sort of like a get or else kind of thing. Okay, so let's duplicate this line. Let's go and say none over here. Right, so if it's a none, then the arrow will be taken. Okay, so basically in the previous one it was a right one. For this one it's a left of arrow, right? So basically a sum is getting converted into the right, and the none is getting converted into a left, because as I already mentioned, like this is the typical way, and either is right biased, it's functorial in its right parameter. This is not the only way though to convert from an either to an option. Cats gives you also alternative syntax. So again, let's say that we have a sum one. Let's for this time say that it's a pure of option, or no, actually let's not do this. Okay, because I believe that this is less confusing. Okay, so you have a sum one, or actually let's do one dot sum. Let's one dot sum. Okay, so you have basically an option, and you can convert it to right like this. But in order to convert it to right, you have to give it something to put on the left, right? So it's basically exactly the same as the same thing as over here, right? You can also do the same thing for none like this. Let's see if this is actually going to work without the type. We're going to have two right here. Left is going to be an arrow, and it seems like it's working, right? So it works, it behaves exactly like this, and you can do exactly the same thing for the other side. So for example, you can create an arrow, right? And you can say that it's a sum, right? So in this case, we have an option of a string, okay? And you can say to left, and this is the one that I find like most confusing. I'm actually never using it, right? But it's basically like a mirror, right? You're saying what to do on the right side, okay? So in this case, it converted it into a left of arrow, so it did not use this one. And in this one, we're gonna do none dot to left like this, and we're going to specify that the right is 1, and in this case it's actually going to go and use the 1, right? So this is the most confusing one. I actually really don't like this one. I don't know, to me it's so confusing. Okay, now either also has a couple of helper methods to deal with exceptions. So you can say, for example, catch only, and you can specify, for example, arithmetic exception like this, and you can give it some code, right? And if it actually throws it, then it will put it into the left. Okay, so it says this is a left of arithmetic exception, right? So the type of this is going to be either arithmetic exception or int in this case. Okay. You can obviously go until throwable like this, and it also has another helper called catch non-fatal. Okay, non-fatal. If you've seen my video from like 2 years ago, if you go over here, it's basically in Scala util control. There is an extractor called non-fatal. It basically pattern matches on a couple of exceptions, which are these ones, right? So basically, it's going to catch everything except for these ones, right? Because these ones are not the ones that you can actually usually handle, right? So what are you going to do if it throws an out of memory error or a thread does? You cannot handle these, and so therefore, it is very common to catch only non-fatal errors. Now, the reason I showed you non-empty chains is because it's a very, very common pattern to use non-empty chains on the left, right? So it's very, very common to sort of accumulate errors, okay? Which is actually not possible to do with either, but we're going to talk about this in the next video. We're going to talk about this more in the next video. All right, so what you can basically do is you can create an A, which is going to be an either of non-empty chain of string or an int, right? So in the good case, we're going to have an int. In the bad case, we're going to have a bunch of strings, okay? So you can go and say left of non-empty chain like this, and let's in this case say that this is going to be a 1. All right, let's do 2 of them. Error 1, error 2, okay, in this particular case. Okay, now because this is so common, there's actually an alias for this type, which is called EitherNec, right? So NEC nec, okay? So you can just say EitherNec, right? You still need to say what is on the left, right? You still have to say like nec of what, right? So this is actually exactly the same thing as I have at the top over there, and it doesn't compile. Why doesn't compile? It's already defined. Okay, so we do a b. Okay, so this is a b. This is exactly the same type as above, right? So we can actually jump in there, and you can see this is either of non-empty chain of error or a. Okay, and you see. Also the other ones. We're going to talk about validated in just a second, and it's also going to have a validated nil, so right, so NonEmptyList, NonEmptyChain, NonEmptySet, even, right? So you have like all of these type aliases. Okay, let's go back. All right, so if we print them out, print line AB, just so that we're always seeing the last thing, print line like that. Okay. And there we go, left chain of error 1, left chain of error 1 and error 2. Okay, so basically you can actually also go and do a print line left of NEC, and let's just do error. Okay, so the type of this, same as before, it's going to be a left of non-empty chain of string or nothing. As same as before, you can go and you can start specifying the types. You can go and say that this is going to be a left of non-empty chain of string or int. Notice that this type alias actually does not help you in this case. Okay, the other thing that you can do is you can go and you can say non-empty chain of error, and then you can say as left like this, int. All right. By the way, this is one of the things that I kind of forgot to show you this. Not to show you this, but like to point it out. Notice that the conversion from like nothing like to left, not like nothing, but like from a regular value to left or to right, you just say as left, and when you're converting, you're saying to left or to right, right? So this is like one of the things that is like a bit confusing. Okay, I still wish that it would have been called just left or just right. Okay, so if you're doing this, then the type is a bit more clear. So now you have your either of non-empty chain of string or int, and by the way, non-empty chain comes from data. All right, so I'm basically showing you like all the possible ways to create this, because you're gonna see this a lot. Like like your team needs to agree on the style and go from there. Okay, so we can do as left int, and then you can go and say left map non-empty chain.1. I've actually seen this one in the code base. In fact, I've actually been using something like this in the beginning before I knew like about all of these like helper methods. Okay, so this one is actually more popular. So this one, error.asLeft int. So this left map to 1, because again it's so common to have a non-empty chain or non-empty list on the left. You can actually go and say to either to EitherNec, right? So notice that we have a regular string, right? And this thing is going to convert this into an either, where on the left, okay, we actually don't see this, but basically it's going to be this type, right? So it's going to create a neck on the left side. The next one is actually the shortest one. This is the clear winner, right? So you can just go and say error dot, and in the case of either, you actually saying left neck. Okay, right? So again, this is a bit inconsistent, right? You know, why is it not as left neck, right? It's just called left neck. And so these ones are very, very popular, right? So it's basically, again, this is like a pure for errors, and errors are very common, like a bunch of them, right? Not empty chain. So you just have an arrow, like one arrow, and you converted it to an entire, you know, left neck of errors, and on the right, you're going to have a string, right? So the type of this is exactly the same as before. It's an either bunch of strings or an int. Obviously, you can go and abuse pure in this case, right? So you can say error dot pure. You can say NonEmptyChain. Okay, so this is one of the ways to create a NonEmptyChain, as we have seen somewhere at the top. Where is it? This one, right? So this is what we did a while ago. Let's go back. Right. So now you basically have a list, and now you can say, okay, raiseError. Okay, and now on the right hand side, you're going to say EitherNec, EitherNec. In this case, at least you could use the the type alias, and over here we're going to have a string. Okay, like this. Great. So this in fact is actually the longest one, right? So this one is the shortest one. This one is the clear winner. And as I already mentioned, I'll probably convert this thing into a cheat sheet. One important thing to know is that you can also do writeNec. Okay, so if you do something like one.writeNec string, an important thing to understand, like before I'm gonna press save over here, it's not going to convert this one into a neck, right? So again, it's very popular to use a neck on the left, and therefore it's going to convert this string. Okay, so basically the type of this is still the same, right? So it's either non-empty chain of strings or an int, right? You basically, so right, so hold on, if you're doing as right, so this is the only difference, right? You're basically pointing out that on the left it should be a neck. Now, Cats also has a thing called validated. It's pretty much like either, but the major difference is that validated does not have an instance of a monad, which is also one of the major reasons why I'm making this video. I'm not going to show you all the ways how to create it, just a couple, because like most ways are very similar to either. So it resides in cats.data, and because we have it imported, it's just going to work, right? So you can go and say a print line validated.valid one, like this. Notice that it's inside of the companion object, so it's also very common to just go and import validated like this. Okay, so you can do validated.valid one, you can do invalid error, and now because I imported it, you can basically do that, and you can do that like this. Okay, right. Now you usually don't need to do this. Like I kind of don't like it when people import this, because again, like Cats gives you like so many cool ways to create this, right? So same as with either, you can say valid, and on the left, right, on the invalid side, it's going to have a string, and you can go and say it's going to be an arrow. You can say invalid int like this, same as before, right? So now this thing actually, it has the type of valid, same as was either. Even though it's defined in Cats, it's still, the type is actually valid, and over here the type is going to be validated, right? So again, it's the same thing as was either. Okay, the other things are going to be same as before, right? So you can go and say one.validNec string, and you can say a print line error dot invalid neck, right? So it's the same as like left and right. Okay, like this. All right, and same as was the either, you can go ahead and say print line, this really gigantic thing where you say arrow pure non-empty chain. Okay, and then you do a raiseError. Okay, you do validated neck string star, and you have to say string again, right? This very, very, very long thing. It works pretty much the same. Now, as I already mentioned, validated does not have an instance of a monad. However, very often you sort of using validated and you want to call flat map, but it doesn't have flat map because it doesn't have a monad, and therefore there are many ways to convert between validated and either. I'm going to show you just a couple. We're going to talk about this more in the next video. All right, so the typical thing, so let's have a print line, and inside of the print line we're going to have a for comprehension, right? So inside of the for comprehension we're going to start with a valid, then we're going to convert it into an either just so that we can do flat map, and then by the end of the day we're going to call to validated so that we convert it back to the validated. Okay, so inside of this we're going to have a for comprehension, right? So we're going to say let's get the one out of the, let me actually scroll down a little bit so that you see the entire thing. Okay, so we're going to have a one. Okay, so we're starting with a validated, right? We're doing valid string, right? But valid doesn't have a monad. Okay, so if you do something like this, right, to as right string like this, it's going to say that okay, actually forgot the yield, you know, 1 plus 2. Okay, so it's going to say, hey, flat map is not a member of validated, and therefore you often go and do like something like to either. Okay, and then you have like two others over here, you're composing the others, you convert it back to validated, and therefore you have the valid 3. Let's do exactly the same thing without the for comprehension. Let's go and do a print line, and let's start with the basically I can just copy stuff, right? So we're going to start with this thing, and I'm going to press enter over here so that Scala FMT will help me out with this thing. Okay, to either, and then we're going to do flat map. Okay, and we're going to have the 1 over here. Ta-da! And I'm going to copy that to as right string like that. Okay, and we're going to do dot map, and we're going to have the 2 over here, right? So this is where we have 1 plus 2. So exactly the same thing without the for comprehension, and now over here we can say to validated. And I'm showing this because with this syntax, you know, without the for comprehension, you're not going to need these, you know, these extra parens or, you know, braces, whatever you use. Okay. Now, again, because this is so common, it actually, so cats actually goes ahead and gives you a special method. So instead of doing like to either and then back to validated, you can just remove that, right? So that's not going to compile because flat map is not part of validated. So what you can do is on the validated, you can say dot with either, right? With either, right? And then this whole thing is going to be a part of it. And with either, it wants a function that will basically take this validated, but it's already be converted, like, so behind the scenes, like to either already happened, right? So this is your either, and you're just going to call flat map on it. Right. So basically, instead of manually converting it to either and then back to validated, this with either thing is going to do it for you. Okay. Maybe it's going to look better like that. Hold up. Like that. Okay. So on the validated, you're saying with either, you're giving it a function that, you know, takes the either and does the either.flatmap, either.flatmap. Okay, so that's sort of like the whole point, right? So this thing, it's already an either string event, and therefore you can call flatmap. Okay, and indeed it actually goes and defines a version of flatmap which is called and then, right? So it basically behaves the same as flatmap, but it does not abide the monadic laws, right? So basically this is sort of like a crutch, and therefore in this particular case you're not even going to need any of that stuff, right? Hold on, let me see if I did it right. Yeah, so basically in this case it pretty much looks as a flat map. In this case I did something wrong. Hold up. Yeah, sort of like the whole point of this was that you don't need an either anymore, right? So you can go and use valid on both hand sides, right? So you're treating valid as if it had flat map, but it can't be called flat map because it doesn't have an instance of a monad, and therefore it's called and then, right? So if you compare it with the regular you know, either flat map version, right? So if you had an either, right, so if this was as right, okay, then you would be able to call flat map, right? So now the code looks basically exactly the same, right? So you can pretty much use validated as if it was a monad. Now, if you find yourself in a situation where you have to do this very often, chances are that you need to learn about the other side of functors. And we're gonna start doing this today, because we're gonna do more of this in the next video, because it's gonna get you know, kind of complicated a bit fast. Okay, so we're going to go to FP library, and we're going to realize that this is obviously not a full picture, right? So there's an entire library, you know, cats or Scala Z or whatever, you know, the whole graph is much bigger, right? So this is just a tiny part. So what we're going to do now is we're going to complete the part a little bit with a thing called apply, which is also the thing that I used in the video about chimney. And over there, we didn't know all of these things. And so I said, you know, I'm just going to grab a fancy thing from cats. You don't need to understand this. I shouldn't have done this, right? This is exactly why I'm doing this video. Now, apply is probably the most confusing one, and this is probably also the reason why most people don't know about this, right? Apply is something that sits between the functor and the applicative. Right, so it's going to be called apply. It takes an f, okay? So it is also a functor, obviously, extends functor like this of some f, all right? And applicative, it actually extends apply, okay? Like this. Sorry, just f, like that. Now a functor, it lifts a function from a to b to a function from f of a to f of b, and apply, it already has a function from a to b, which is already in the context f. Okay, so the first time I'm gonna write it basically in the same syntax, in the in the categorical theory syntax. Okay, so it's a function. It's very similar to map. In fact, it's closer to flat map, which is what we're gonna realize in the next video. Okay, so it basically same as before. So before it was a function from a to b. Okay, but in this case, this whole thing is already inside of a context, right? This is kind of weird, but it's already inside of a context, okay? And but it produces exactly the same thing, right? So it basically, it sort of like separates this function, right? Sort of like splits it apart like this. Okay, and as I already mentioned, like it's more common to rearrange it, right? So it's more common to basically just take this f. Okay, so how I'm gonna do this? I'm gonna cut this out. I'm gonna remove that. Okay, and I'm just gonna put it over here like that. Okay, so this is an f of a. Okay, like this. Okay, I'm gonna remove this one. All right, there we go. So this thing is very similar to monads. In fact, let's add monads real quick, and we're not gonna concentrate on monads. I just wanna show you the similarities. In fact, I'm gonna do this. I'm just gonna do that, and I'm gonna go down over here, and we're gonna say that this is a monad. Okay, and I'm going to say that it extends applicative, right? Monads actually always extend applicative. This is also one of the important things that you need to realize in this video. And so monads, they have flat map, which looks pretty much exactly the same, but for monads, only the B is inside of an F, and the A is not. Okay, this is the only difference, and we're gonna play with this a lot in the upcoming videos. Well, actually, only in the next video, which is probably gonna be very long. I actually was kind of hoping that this one would be short, but but I'm recording already for more than an hour. Jesus. Now this whole thing is kind of abstract, and in fact, maybe I want you to see the whole sort of like the whole picture, like this. Okay, so this is the whole thing. Now, obviously, instances of these are defined in cats, but just for science, I'm gonna define an option of a monad, which is also saying that we're gonna define an instance of all of these. Well, maybe not applicative error, but by the way, there's also monad error, but I'm not gonna show it to you because I don't want to confuse you. We're not gonna play with monad errors at all. Okay, so basically, I'm gonna go and define a monad for options, just so that we see the so that you can better visualize the implementation for map, and especially for app, right? All of the others are going to be kind of, well, actually the entire thing is going to be very simple. Okay, so I'm going to call it monad for option.scala. Okay, I'm going to go and I'm going to copy the imports like this, like that, not the imports, the package. All right, so I'm going to go and say option monad for option extends monad option, like this. All right, and Bloop should go, and Bloop and Metals, they should help me to implement all of them. So let's do, even though they're sorted differently, right? So functor is at the top. I want to do pure first. So let's do pure first, and then we're gonna do map, and then we're gonna do app, and then we're gonna do flat map. Okay, like this. So this should compile now. All right, so pure is just a factor, right? So it's just sum of a. Super simple. Okay, map, and the same way as like most of the others are gonna look like, is actually very similar, right? So map, all map, app, and flat map, all of them are gonna start with the pattern match on the FA. Okay, so we're gonna do I'm gonna type it over here, right? So we're gonna do FA match. Okay, like this, and I'm gonna say case sum of a. Let's do something, and in all the other cases, which is basically none, we're just going to return none. Okay, so what can we do over here? We have an a. Well, we might as well just call f of a. Okay, like this. I'm sorry, just f. Okay, all right. In fact, maybe I should call it a to b or something, And yeah, we obviously need to do this. Okay. Now there's also a way to, like, combine these, right? So instead of sum, I could have said pure, right? Sometimes I'm gonna do this. Sometimes I'm gonna do that. Yeah, I'm gonna keep doing that. Okay. Now let's go into flat map. Flat map is very, 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 very simple, right? You just do that, and you just don't need to do this sum. Okay, like this. All right. And app is also going to be very, very similar. I'm gonna do that. So if it's a sum, then we're going to take the app, which is now an option, right? We're just going to say map, right? But what's inside of app? Well, inside of app is a function that goes from A to B, right? So this is a function, and we need to produce a lambda over here, right? So we're calling map, and in this case, we're just going to apply the A to that function. Okay, so this is the app. Not sure if it's kind of complicated to understand, but basically, yeah, not really rocket science. One of the reasons I'm showing you this is because app is the only one that has two options that it can play around with. So an alternative implementation for app, let's call it app2, okay, would be to say, let's pattern match on app. Okay, so you can do pattern match on app. So this is not an A, this is AB. Okay, and then we can do f of A over here, right? So we're mapping on this one, right? And it basically will need just a function from A to B, right? So this is another alternative implementation. It's also a bit nicer to read. The point is that app, like this original implementation, in fact, I'm going to throw this one out like this. Right? So this app, this original implementation, is very, very similar to flat map. Now, technically overriding all of these methods does not make this thing a monad or applicative or whatever. There are also laws that this thing needs to abide. However, this is not the topic of this video, so we're just going to pretend like this is okay, right? For us, this is a monad, and also this is where I will break up this video, and in the next video, we're gonna concentrate much more on the applicative functors and on the similarities between applicative functors and monads. I'm going to see when to use which and when to use, yeah, basically when to use which. And so, without any further ado, as always, it's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on Patreon. But most importantly, take care.